Okay. So highlight that part. That's the last section in this booklet. I would say if you're not familiar with the names, right, I would say study sheet. That chart, so common names, right? I would just fixate on the prefixes. So tri is 3, right? Quad is 4, pent is 5, hex 6, hept 7, oct 8, nona is 9, deca 10, dodeca is 12. What happened to 11? We just call it 11-sided. I don't know why. Like, there's probably a name for it, but we won't worry about that. So after that, after 12 sides, we call it n-sided polygon. N-sided polygon. So if it has 20 sides, we would call it 20-sided polygon. 30-sided polygon. So there's no more naming it after you get. But on a test, I'll say, hey, calculate this for a nonagon. You're gonna have to know how many sides, right? Can you add this in your notes? Number of sides in polygons is actually n. The number of sides, we use the letter n in place for it. Okay. And so triangles and quadrilaterals, notice this, right? This was the first shape we studied. Then these are the second category, right? We had our trapezoids, our kites, our rectangles, all of that. They fall into polygons. Keep that in mind. Okay. Okay, and the bottom section is empty for a reason. So on your study sheet, okay, back. I would probably assume that most of you know 3, 4, 5, like up to penta, maybe even up to hexa. I don't know if you should just add the 7 and up, like within, just to save space. I don't know, if you want them all, go for it. But don't use up too much space for it. It's just good for you to know. And then here I need to add stuff. So regular versus irregular polygons. Regular, watch this. All sides are congruent. Therefore, all angles are congruent. Irregular, it's only some might be congruent. Some might be congruent, but not all. Okay? So that's the biggest difference between regular, irregular. So watch this. A square is actually a regular polygon, and all angles are the same. And this is a little controversial, but a rectangle would be considered an irregular because, yes, these two sides are the same. these two sides are the same, so it fails the all sides are congruent test. Okay, even though all angles are congruent, okay, fails all sides are congruent test. Okay. So that'd be irregular. And you have your, which triangle would be considered a regular? What do we call it? Equilateral. Yeah, so boom, boom, boom. Equilateral is a regular. And would isosceles, would that be a regular? No, it would not be. Okay, because only these two are the same. This one is different. Okay, fails. So this isosceles obviously fails all angles congruent test. So it's either they have to meet both of these criteria. Both criteria need to be met for you to be under the regular polygon category. Okay, so there you go. And I kind of ate up a lot of space, but that's okay. That's all I needed there. So here, how about we do this? Check mark, check mark. Like if these are both right, and then check mark, check mark. Both of those shapes qualify because they pass both of those tests. Okay. All right, that's it. So you need to know the difference between regular and irregular, because the test will have some multiple choice this time. And it's these kind of questions that I will ask you just to check if you're understanding these concepts we're covering. Backside. This I inserted here. So make sure you write these formulas down and make sure they make it onto your study sheet. Okay? They are also on the yellow formula sheet. Try to hurry right through, okay? Because this is important. The sum of all interior angles, the letter S is used. Can you just, I'm going to change it a little bit. No, I'll just leave it like that. That's okay. S is going to be n minus 2 times 180 degrees. And remember, n is equal to the number of sides. Okay, just make sure you understand that. So let's think of a triangle. How many sides does a triangle have? 3, right? 3 minus 2, 1. 1 times 180, 180. Did we know that already? Yeah, we knew that, but it works, right? So that's how you find out, and this is always true. Always true, regular or irregular. Okay, so that works regardless of if it's regular or not. This formula works every time. Each interior angle, the letter capital I is used. It starts off the same, watch. N minus 2 times 180, but you're going to divide that by n. So this is capital I. If you want to make sure you understand that, that's a capital I there. And that's how you calculate that. Central angle, it's denoted by the letter C. It's simply 360 degrees divided by n. exterior angle, watch this, it's exactly the same as the central angle. Same formula. 360 divided by n. And this one, I always need to double check. Where are you, diagonals? One second. I think it's minus 3 times n minus 3 times n divided by 2. I'm fairly certain that's the formula. I think I'm going to go with it. I don't. Anybody have the formula sheet handy there? I see that you have it. I'm going to double check. N times n minus 3 divided by 2. There we go. N times n minus 3 divided by 2. Sorry, you can't see that, right? This is how you find the diagonals. And I will draw that in a bit on each of these shapes that you see there. Whole number. This is always going to give you a whole number. If you're trying to figure out the diagonals and you get a decimal, you made a mistake. You got to go back. Okay, very important. So let's start with the diagonals because that's where we're at. Diagonals are, if you go from one corner to the other like that, that's one diagonal. You can make another diagonal here. I'm going to switch colors. You can make a diagonal from here to here, from here to here, and you can make a diagonal from here to here. Right? So how many diagonals are we counting here? 1, 2, 3, 4, and 5, right? 5 diagonals for that particular shape. We're going to put that to the test. On next time we meet. Unfortunately, I ran a little bit out of time here, but we'll leave it at that, like that, and then continue next time.